suck out the gas is because gravity is holding the gas to the Earth.
Yeah, exactly.
Because everywhere else in science, when there's a vacuum and gas, it equilibrates.
Yes. If you just take without gravity, yes, then they start to mix. Yes.
Okay. On to the next question. It is written in astrophysics that the rotation of the Earth is due to, we can't feel it because of constant velocity. Now, one astrophysics guy I met, he said there are two constant speeds. Let me show you this.
Yes.
A bit like this fairground ride.
Yes.
And some people I know looked at some rotation physics, and they said if you're on the edge of this, you would be experiencing acceleration and deceleration. It's only the middle point that would experience, like the wizard in the middle. The wizard would be constant velocity, but if you're on the edge, you get acceleration and deceleration because of the two constant speeds. How would you answer that?
You mean why this happens? Or
Well, surely with the rotation of the Earth,
yeah,
and because it's going around the sun at 66,000 miles an hour,
yeah.
would be experiencing deceleration and acceleration. So think of this fairground ride. Pick one human being. So pretend that's the Earth.
So you want to include all the velocities involved, also Earth
Just two.
rotation.
The Earth rotation on its axis, 1,000 miles an hour, and 66,000 miles an hour around the sun. If you're on the edge of this sphere, like a human being, you would surely be experiencing deceleration and acceleration.
Exactly.
How does astrophysics at your level explain that?
Well, it's gravitational forces. So one gravitational force you have towards the Earth center. So this is gravity of Earth, and that what holds Earth together. And when it rotates, you experience this acceleration on the edge of the Earth and the gravity towards the Earth. But when the Earth goes around the Sun, there is gravitational force towards the center of the Sun. So two gravitational forces produce this effect of acceleration and deceleration combination.
But wouldn't that mean we're not at a constant velocity, so humans should feel the rotation of the Earth?
That is interesting.
It's an interesting one.
Yes.
The astrophysicist I met, he did a model showing that it should show acceleration and deceleration. So I could actually show you a video where this goes around the sun, and it shows, and even you can go onto the International Space Station, which is orbiting the Earth, and this also should be showing acceleration and deceleration due to the two constant motions, just like the fairground ride.
Right. Well,
probably needs some homework.
Yeah, I need some thinking.
But it's an interesting one, yeah?
It is an interesting question, yes. We usually think, that the pull, we have to compare this acceleration to the gravitational pull.
Okay.
That's I would start with. Because velocity is one thing, but acceleration is the other thing. So we have to compare acceleration due to rotation to the acceleration due to gravity.
Yeah.
And it's very possible that gravitational acceleration is larger. That's why we just don't feel this side.
I think we would need three different answers. One for the Earth, one for the International Space Station, and then one, imagine an astronaut outside the International Space Station. How would he be staying with the space station? Because they're all doing this they're all acting under these two constant forces, two constant motions.
Exactly, yeah.
So this is a question I can't get answered. It's a very interesting one.
Yeah, but in this case, space station and the astronaut in space, they are like we call it probe particles, free particles to probe the gravitational field, yeah? So they will orbit the Earth because of the gravitational pull of Earth, but together with Earth, they will move around the Sun. So, and that is because the gravitational acceleration of the Earth to the Sun is much larger than gravitational acceleration of any of us to the Earth.
So they just don't notice it?
Yeah, they don't notice this.
Okay.
So that is, I think this, of course, the rotation around the Sun, orbiting around the Sun, it's a huge velocity. But we're so pulled to the Earth that this Earth to the Sun is somewhere.
Yeah. In the 1700s, on the same theme, James Bradley did an experiment which was redone in 1871 by a G. Airy. Obviously, this is a long time ago. And also the Michelson-Morley experiment in 1887. All these detected no rotation of the Earth. It's a bit of a silly question.
They detected no ether.
No ether. Yeah, I've read this.
Yes, no motion of the Earth with respect
to the sky.
Motionless ether. That's the measurement. So they disprove that there is ether.
Okay. Yeah, this could be interpreted in many ways. So what scientific method, instrumentation or experiment would you say proves the Earth is rotating? What would be your first, number one best proof if you were doing a lecture?
That we see sunsets and sunrises,
Okay.
moonsets and moonrises, yes. This is the first, we see sky moving, basically, yeah? So.
But, obviously back in the old days they would say the sky's moving.
Yes.
Yeah.
So, but now we know this is if we understood that we are humans, not us. Humans are not in the center of the universe, if you take this Aristotle system, we are in the center of the universe.
It's funny because the Planck probe in 2013 did say we are the center of the universe. I don't know if you ever studied that experiment.
Yes, Planck, I don't know why they said it. It's like we're in the center. Yes. That's, I want to tell this. So
sure, okay.
Aristotle said, okay, we're in the center of the universe, Earth, and everything around rotates. Yeah. Then Galileo and Copernicus and Kepler, they said, no, there is the sun in the center of the universe. Yeah. Then Hubble came 100 years ago, said that, we see that all galaxies are moving away from us. It doesn't mean that we're really in the center of the universe. Yeah. But then later we found out that space expands. Einstein said that no, the galaxy is moving fine, but it's not that because we're in the center of the universe. It's because space expands at every point of the universe. So every point of the universe could be wherever you were in the universe. You would see that everything expands from you. So you would always feel I am in the center.
Let's go on to gravity. This probably come across as a very obscure question. So these people said to me, gravity is strong enough to hold boats and cargo and cars to a spinning ball, but yet it's not strong enough to pull the butterfly down or these small areas of these dead flowers. How would you answer that?
This is the buoyancy. Yeah. So when it's the same question, how can we swim in water? So why don't you fall to the bottom of the swimming pool?
Buoyancy.
It's buoyancy.
But then couldn't gravity be explained away? Because gravity is a theory, yes? It's a worldwide agreed theory. It's not, I don't think anyone's got the graviton.
It's a theory, but it's very well tested and very well confirmed. Even though we don't see graviton, it's still very well tested. Yes.
Could gravity be explained away with density and buoyancy?
It's not gravity. I said it's buoyancy. It's combination of buoyancy and gravity.
Back to the butterfly. Yes. Yeah.
So you swim in a swimming pool or ship on the water. You have two forces again. So in every physics study, this for students, they need to take all forces into account, which are essential. So in this case, one goes down, gravity, and one goes up, is buoyancy. And you can swim when on the surface. When at the surface, these two forces are equal. So if you go down, gravity will be stronger, but buoyancy also will be stronger. So then you can float.
How does that affect the dead part of the flower?
It's the same. Atmosphere is the same as a swimming pool. There is atmospheric buoyancy.
Okay.
So it's the same for light creatures like butterflies and dandelion. I don't know how they call them in English.
And
how these things are called in English?
It's called a dandelion.
Yeah, the whole thing. But this one?
I don't know. There's no such words.
So they're also floating because the buoyancy for these things is much larger than gravity. The mass is very tiny, but they are puffy. So for them, the volume is bigger than the mass. It's the mass ratio volume to mass, basically.
Okay.
So, and the volume is much bigger than the mass, and so the buoyancy is much larger than gravitation. And for the butterfly, I guess they can coordinate that.
And it would be the same answer for gravity strong enough to hold the moon in orbit.
Yes.
but astronauts can float about and pretty much choose what direction they go in.
No.